I'm Jen from Nervos. I'm the co-founder and architect of Nervos, which makes me a little bit nervous. Okay, so in the next 20 minutes, I'll talk about what is layer one and what's the problem with layer one, and how can we solve the problems. Here's my definition of layer one and layer two. First, Nervos is a blockchain project tries to define layers of protocols to build a crypto economy. We don't want to solve all the problems by a single blockchain, but we want to build layers of protocols and a network. We think the key to understand the difference between layer one and layer two is the consensus scope. We believe that the layer one blockchain must have the broadest scope of consensus, which means you must have a global consensus, right? But by global consensus, I mean it must be a permissionless blockchain that anyone in the world can participate in the consensus process. Such a layer one blockchain can be the trust anchor of crypto economy. And layer two blockchain or protocols can have smaller consensus scope. The participants of layer two can be from a single country, right, or a single industry. That's a smaller scope of consensus. And the reason we do such a separation is we can exchange consensus scope for other benefits like higher throughput, lower latency, scalability, etc. And we need to build protocols to bridge the layer two and layer one protocol. And we also need to notice that scalability is not the only reason we chase for layers of protocols. Layering is a general method for separation of concerns. We can solve different problems on different layers. Like we talked a lot about regulations today, right? And the question is, how should we do regulations to Bitcoin or to make Ethereum compliant to our current regulation framework? But in our opinion, layered architecture is also the answer to regulation or compliance problem. Like we think the layer one blockchain must be neutral, like internet is neutral, right? And we can have compliance on layer two because the layer two might be a permission blockchain or it's a state channel network. We can also solve the security versus user experience problem by layered architecture, because we all know that if you want to keep your private keys safe, you must sacrifice some convenience. It's the same for blockchain. If you want to make a blockchain as secure as possible, you must sacrifice something else like performance. But with layered architecture, we can chase for security on layer one, but we can sacrifice a little bit of security on layer two to exchange for better user experience. Like we can have state channel aligning network on layer two for lower latency, right? That's actually a user experience trade-off. So with this thinkings and definitions, a natural question is, can any blockchain be layer one blockchain? Right? We don't think so, because we think a layer one blockchain must prioritize decentralization and security over other things. We can only have censorship resistance with decentralization. We need to chase the highest security in layer one, because layer one is the root of the whole crypto economy. It's the trust anchor of the whole economy. Typical layer one blockchains are Bitcoin and Ethereum because they have very broad consensus scope. And a lot of public blockchains today, they are actually not layer one blockchain in this definition. They are layer two blockchains. For example, I think EOS is a layer two blockchain because it has a smaller scope of consensus. And it also has some constitution that regulates itself. So we can see there are some problems with existing blockchains today, which are the obstacles for them to become a layer one blockchain, even for Bitcoin and Ethereum. I will talk about these three problems one by one. The first is the tragedy of storage commons. We all know that blockchain is kind of a common resources. That's why we need to pay for our transactions to use the blockchain. But the existing economic model for Bitcoin or Ethereum only considers the cost of computation and maybe network bandwidth, but none of them considers the cost of storage. Like every user in this system, they can pay only once, but store their data on blockchain forever. That makes the blockchain storage a common goods, and people will abuse the storage to store anything they want forever on the blockchain. And all the full nodes need to incur the costs of storage. Why is this a problem? Is it raised the barrier for participants in this network. Imagine you have a blockchain with like over 1 terabytes state. Then not everyone can synchronize the state and history of transactions easily. And if you can synchronize the state easily, it's hard for you to verify the state or the transaction history by yourself, which undermines the trustless property of blockchain. And that's the core value of blockchain. Ethereum has realized this problem. That's why Ethereum has proposed like EIP 103 storage rent to solve the problem. But we think it's a suboptimal solution. In CKB, we propose a new state model, which is basically a generalization of UTXO. Because in UTXO, you can store amount, the value of Bitcoin, in an UTXO data structure. But we generalize UTXO to store arbitrary kind of data, and we generalize amount and integer value to capacity, which is used to specify the maximum size of a cell. In this way, we bound the native asset. We bound the number of a native asset with the state size in this system, because now the space, the cell capacity is the native asset in this system, right? So what you can transfer is consensus space in this blockchain. And because any cell, the capacity occupied by any one cell cannot exceed its capacity, the whole system state size or the capacity occupied by all the cells cannot exceed the total capacity in this system. In this way, with carefully chosen inflation curve, by inflation curve, I mean the inflation curve for cell capacity, we can make sure that state size is not a problem for non-professional nodes. So anyone can participate in this network and they can verify the whole history. They can verify the state by themselves. So the problem is this, and our solution is make the consensus state the native asset. The next problem is what we call starving layer 1. Because if we want to scale with layer 2, there's an obvious problem here, which is if we scale on layer 2, there will be naturally less layer 1 transactions, and which means lower transaction fees for miners, which leads to lower mining rewards to miners, which will lead to lower layer 1 security, right? But we need a secure layer 1 to support all those layer 2. This whole system contradicts with itself, right? That's what we call starving layer 1 problem. If we scale on layer 2, layer 1 will be unsustainable. So how can we solve this problem? We need to distinguish different kind of users. We have store value users and we have utility users. For store value users, they use the native asset as a method to preserve value. And for utility users, they use cell. They use cell capacity to store consensus state as a storage. And for SOV users, they hate dilution. For utility users, they incur costs to nodes in the network, and they must pay something to miners. And the payment must be proportional to time and space, both time and space. So in CKB, we have a mechanism called dilutionless inflation. So we will have constant fixed inflation to everyone. So everyone pays to miners, indeed, right? And for those SOV users, we have some way for them to get subsidized. So they actually pay nothing to miners. We leave only those utility users to pay their usage of capacity to miners. But those SOV users will never get diluted. We will release an economic paper very soon. And if you are interested in this model, feel free to talk with me. So in this setting, in CKB's token economics, miners always get paid, even if there's 0 transaction on layer 1. In such a way, we can be compatible with store of value layer and layer 2 scaling. So there is a problem we call starving layer 1, and the solution is dilutionless inflation. The third problem I want to talk about is the lack of crypto primitives. Why is this a problem? It's because users want different crypto primitives to have different lock scripts or different signature algorithms. Users want Schnorr signature or BLS signature, right? And if you want to build a layer 1 blockchain, you need to consider how to interoperate with those layer 2 chains or layer 2 protocols. Someone proposed ZK Snark Plasma in Ethereum community, but how can you implement ZK Snark Plasma on layer 2 without a ZK Snark verified primitive on layer 1 on Ethereum, right? And you need to interoperate with other blockchains. Someone in Ethereum community proposed bake2b hash function to ask the Ethereum team to make it a precompile, which is basically something like an opcode in EVM. Why does he propose this? Is because he wants to bridge Zcash and Ethereum, so they can so users can send transactions from Ethereum to Zcash or from Zcash to Ethereum. But such a proposal hasn't been implemented until now, although it's proposed 2 years ago. So the lack of crypto primitives is an obstacle to fast evolving and also a problem for layer 1. What we did here, what CKB did is we built a very abstract virtual machine. There's no hard-coded crypto primitives in CKB VM. It's not like Bitcoin VM or Ethereum VM. For example, there is a OP check seek opcode in Bitcoin VM, which is used to verify the SecP signatures in Bitcoin transaction. But in CKB, SecP primitive is nothing special than a user-defined script or smart contract. CKB also uses SecP as its default signature algorithm, but it's running in CKB VM, not a hard-coded crypto primitive. It's compiled to ELF from Bitcoin Core standard library and deployed by a normal transaction. Why is CKB the first to do this is because running crypto primitives in virtual machine is quite slow, right? If you want to implement this in EVM or other VM, it's slow. But we have did some optimization work, and the result is good. A single SecP verification costs 9 milliseconds in CKB VM. For comparison, the same algorithm running on native CPU costs about 1 millisecond. So it's within tenfold. Why is this useful? It's because now user can define their crypto primitives by themselves. And most crypto primitives can be ported easily because CKB VM adopts RISC-V instruction set, which means any language, any programming language that can be compiled by GCC can be compiled to CKB VM instructions and run on CKB, which is also good for security because we always say that don't implement your own version of crypto algorithms. You will always do it wrong. So there is a problem of lack of crypto primitives, and we built a very abstract virtual machine. We believe that CKB can solve these problems. That's why we called CKB the layer 1 blockchain. Any questions, Francois?
Yes. If SecP 256 is a library and storage cost, who is going to pay the storage for that particular thing? And how do we know that it will still be there when I need it? It will not be destroyed like the priority wallet destroyed when everyone relies on it.
Yeah, very good question. So for some very basic libraries, the foundation will compile them and deploy them. So the storage cost is paid by Nervos Foundation, and and it's easy to prove that it will never be deleted by using some special lock script, because you leave the lock script empty. It means no one can reuse the cell capacity.
There's no guarantees if a community member uploads their own crypto parameter that it will always be there.
If the community member wants to guarantee that, he can always do that. He can also leave the lock script in a cell empty or cannot unlock by anyone. So it depends on the developer it depends on whether he wants to prove that it cannot be deleted or what.
Do you plan on also providing a package manager or anything like that to index all of these packages that people upload and with ranking or anything of that sort?
We hope that our community will build it because like the packager package thing is kind of standard, and we have defined a open RFC process, request for comments, so anyone can submit an RFC and propose his package manager to be the standard for the community. Thank you. Thank you.